Hey guys, how's it going? I'm using this screencast to show you a GSP file for my UDL lesson because many of you don't have Geometer Sketchpad on your computer unless you're a math teacher. It would be really hard for you to follow the lesson if you couldn't see something to go along with it. Now there are a whole bunch of pages in this that I use for different portions of the lesson, but this page is the main portion for at least after we finish or use the Discovery Lab. This is kind of a verification for the kids, and they can see much more variations in functions. You'll see I have a function up here. I can also change the axis of revolution. It's just another type of visualization than the TI CAS Inspire, which has great visuals as well. This one's just a little bit more tactile, and this one's a little bit more editable. And sometimes the interface of a calculator really isn't as intuitive as a computer for most students. So what I have the kids do is I allow them to, we talk about rotating around a horizontal line. So normally I have them work with it right at the x-axis. Undo that. What we do is we start working around, moving this to the x-axis. So you can see by clicking this button here, I can bring that up to the x-axis. And then I can let the kids choose their own function. I normally have square root of x put in there. You can use, I ask the kids to change one. They can pick whatever they want. For example, I guess we could just change it to, we can modify it to 2x or something along the lines of that, and we'll hit OK. So you see it just changes the function a little bit. The endpoints change, but it's really just a cool visual. It's really hard for at least my students, I mean really any 16, 17, 18-year-old to visualize some of these 3D solids. So this is a kind of a nice way that we can help to compensate that and kind of makes the learning accessible to everybody, not just the people who are kind of the to have a little bit better visualization skills, and not just the people who are good at the processes. We want to make sure that we can access the students with conceptual work too. So let's get to this. That way at least you guys can see what this program looks like. So like I said, we set our function, we set our endpoints. Cool thing here, look, I can revolve it. So now the kids can see what the shape of the cross section is, because that's really the big objective, is for them to see what the cross section is. As you guys can see, it is a circle. It's really cool as we can move this x value and show that no matter where it is, it's a cross section of a circle. Like I said, really interactive. And then the cool thing is we can just sweep a disk through it. So you can see as we constantly are taking slices, it's a circle, which is really helpful for the kids. One, because it's, like I said, much more visual, and they can see infinitely many examples as opposed to having to draw it out and try and visualize it. It also helps them see the shapes. Is it a bullet shaped? Is it kind of like the end of a trumpet? Is it like a salad bowl? Stuff like that. And like I said, I'll just show you guys just another function real quick, just to show you how it works. Let's do x squared. Okay. And you'll see, switches the function for us. I'll move our endpoint down so we get a little bit better view. Move this endpoint down a little bit so we get a little better view. And then we'll do the exact same thing. Revolve. The kids will see that even for this example, our cross section is still a circle, and they can see it again that it's moving in real time. Really cool. Engages a lot of kids because it's, one, intellectually stimulating, two, it's an investigation lab, so it's really helpful, and three, it's just very easy for them to manipulate and kind of make it their own, take a little bit of accountability for their learning. This, in conjunction with a CAS file, I'll make sure I upload that as well, gives the kids some options as to how they want to approach this Discovery Lab. They have some options here, making the learning a little bit more accessible for everybody. Some people can do it by hand on paper. Some people can draw it out on whiteboards. Some people will be using the CAS, and kids have this as another option as well. Well, I hope this kind of gave you guys a better idea of what the function and what the file looks like, and kind of see how this design really matches up with my lesson plan and why it really fits that UDL format. Also check out the UDL checklist because that has some topics similar to this as well. Thank you guys for listening.